everyone, good morning. Today we're going to be doing AMC-8 2022 problems and solutions. You might be wondering why we skipped 2021 because last class was 2020. But we skipped 2021 because of COVID and therefore there was no AMC-8 during 2021. And so we're going to go directly from 2020 to 2022. And so the agenda for today is that we're going to be doing the AMC-8 2022 problems, and you can ask some questions and answers towards the end of the session, and we'll be discussing about key strategies and tips to improve your score on whether a specific AMC-8 question or maybe just like in general. And let's get started. Problem number 1. The math team designed a logo shaped like a multiplication a logo shaped by like a multiplication symbol. Shown below on a grid of 1-inch squares. What is the area of the logo in square inches? So we know that each of these squares are worth 1 inch. So 1 by 1. So each of it is worth in total 1 square inches. And square inches are just a measurement for the area. So to find the area, it's always going to be something square unit, whether it's a square or whether it's not a square. It's always going to be something square units. So the area of this would be something square inches, since they told us that the measurement is in inches. And so to find the area of this, we know that there's going to be these in the middle. It's going to be a square. And well, how many blocks are there? Well, there's going to be 1, 2, 3, 4. So there's going to be 4 squares in the middle. And so the square over here is worth 4 square inches. Well, what's the measurement of these, the outer parts? Well, to find the measurement of that, we know that this right here. So suppose that it's like this and this. Suppose that it's something like this. Then if we would combine those two, it'll make 1 square. So if you put this part of it over here, it would just make 1 square, looking something like this one. So we know that this triangle over here, is going to be worth 1 square unit. So if this one's worth 1 square unit, then what would this one be worth? Well, since both of these are the same, these both would be worth 1 square unit as well. So this one will be 1 square unit, and this one will also be worth 1 square unit. Well, what about these ones? So to find the area of these triangles right here, well, once again, if we combine both of these together, so if we combine this one and this one together, just place this one over here, and it'll be making 1 square again. The same thing applies to this one, it'll be making 1 square again. So we have 4 in the center, the square in the center, plus the 4 here. So 1, 2, 3, 4, plus these 2 right here. So 1 and 2. And so if we would add all of these together, we're going to be getting 4 plus 4 plus 2, which is going to be giving us 8 plus 2, which is going to be equal to 10. And that's how we got our answer choice A. Problem number 2. Consider these two operations. A diamond B is equal to A squared minus B squared, and A star B is equal to A minus B parentheses square. So what is the value of parentheses 5 diamond 3, a close parentheses star 6? So we know that following the order of operations, we're going to do parentheses, exponents, multiplication, division, addition, and subtraction. And so parentheses comes first, so we need to solve what is in the parentheses. Well, what's in the parentheses? It's going to be equal to A, so we're going to write the equation right here. So A minus B squared. And that's going to be equal to 5 squared minus 3 squared. And 5 squared is going to be equal to 25, just 5 times 5, and minus 3 times 3. And 3 times 3 is going to be equal to 9. So 25 minus 9 is going to be equal to 16. So now we can do 16. So 16 star 6. 16 star 6. And that's going to be equal to A minus B in parentheses squared. So we're going to do 16 minus 6 squared. And that's going to be equal to 10 squared, since 16 minus 6 is equal to 10. And 10 squared is just simply 10 times 10, which is 100. And that's how we got our answer choice D, 100. Problem number 3. When three positive integers, a, b, and c, are multiplied together, their product is 100. Suppose a is less than b and b is less than c, then how many ways can the numbers be chosen? So first we can list out all of the factors of 100. So the factors of 100 are just the numbers. So suppose that 1 times 100. If you multiply 1 times 100, then that should be equal to 100. So 1 times 100, so 1. 2 times 50, so 2. 4, 5, 10, 20, 25, 50, and 100. Well, how many factors are there? So there's going to be, this is 100, so there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 factors. So, uh, so now suppose that A is less than B and B is less than C. What's A, B, C? Well, that's what we need to find. So, suppose that we have 1 as A. So 1, comma, 2, comma, 50. Can this work? Well, A is less than B and B is less than C, and all of these have to make up 100. 1 times 2 is 2, and 2 times 50 is 100. So this can work. How about 1, 4, 25? Can this work? Yes, because 1 is less than 4 and 4 is less than 25. So it's going to be 4 times 25, which is equal to 100. How about 1, 5, 20? Can this work? Well, 1 is less than 5 and 5 is less than 20, and 5 times 20 is equal to 100. Well, can 2, I'll write this right here, so 2, 5, and 10 work? Well, 2 times 5 is going to be equal to 10, and 10 times 10 is going to be equal to 100. So this can work. These are the 4 ways that these numbers can be chosen. And we can just do trial and error, or so we know that another way to do this is that we know that 2 times 50 here, 4 times 25 is here, so we can just cross this up. 4 times 25, 5 times 5 times 20 here, and we also have 2 times 50. Obviously, we can't do 100 times 100 because that's way more than 100, so we can't use 100 at all. And we're going to be left with 10. Well, 1 is already crossed off, so 10. Well, 10 times what is equal to 100? 10 squared is equal to 100, so 10 times 10 is going to be equal to 100. But we can't do 1, 10, 10 because A has to be less than B and B has to be less than C. So what other ways can we make 10? 2 and 5. So 2, 5, and 10. So that's how we got 4 different ways to make 100, assuming that, or we have to make sure that A is less than B and B is less than C. And so that's how we got our answer choice E. Problem number 4. The letter M in the figure below is first reflected over the line Q and then reflected over the line P. What is the resulting image? So they told us this right here. They gave us an image just for reference. So the letter M is right here. In the figure below is reflected over line Q. So think of it as a mirror. If you look into a mirror, then that's your reflection. That's called reflection. So it's gonna show the same thing. So here, you know mirror image. So if you suppose that you write AMC and you show it to a mirror, is it gonna appear the same? Well, no, because those letters are not the same. So if you draw a circle, is it gonna be the same in the mirror? Yes, it is, because the circle has an infinite line of symmetries, which means that you can cut the circle in any way. You can, so suppose that this is a circle here. Okay, so you can cut it this way, this way, this way, this way, and any way possible for a circle. But for most of the other shapes, you can't really cut it into an even, like, into as many lines of symmetry as possible. And so here, think of it right here. So you can like take a piece of paper and you can cut it into a square. And then you can draw a line in the paper, something like this. Something like this. So here, I have this right here. And so when you draw the line, I'm just showing this square right here. Can you see that? This square right here. And so I drew this. So when we fold this in half, since it reflects over line Q, first it reflects over line Q. So then it will be going like this. Well, if it would reflect over line Q, then it should be, so this is it right now. And then it should be looking something like this. And so the M should be appearing sideways. Sorry, the M should be appearing sideways like that. I'm not sure if you can see it, but yeah, the M should be appearing sideways like that. And so I'll just draw this here just in case you couldn't see it. And so the M should be like that since it reflects over line Q. So now we know that after that it reflects over line P. Well, if it would reflect over line P, this is how it should be looking right now. You can also draw this in a piece of paper and you can try it on your own, just as an experiment. So if it would reflect over line P, then it should be looking something like this. So then this would go over here, and so it would be looking something like this, or something like this. And so which one of these answer choices would be looking something like this? Here. Which of these would be looking something like this since it was originally here, and then we did a line of symmetry over here, and so the M moved over here, and then we had to reflect over line P, and so it would go over here. And so the one that is the only answer choice that is correct is answer choice E. You might be thinking that we won't be having a paper to do this on the AMC-8, but actually we'll be having paper so that you can like rip out a piece of paper, or like they'll be giving you scratch paper on the AMC-8 so you can just try this on your own. Or maybe if you're really good, if you can really visualize really well, then you just can visualize. If you can visualize, it'll also save some time. So yeah, and that's how we got an answer choice E. Problem number 5. Anna and Bella are celebrating their birthdays together. 5 years ago, when Bella turned 6 years old, she received a newborn kitten as a birthday present. Today, the sums of the ages of the two children and the kitten is 30 years old. How many years older than Bella is Anna? So, we know that Bella and Anna are both celebrating their birthdays together. So, 5 years ago, Bella turned 6. And then she received a newborn kitten, so the kitten would be 0 years old as a birthday present. Today, the sum of both of the children and the kitten is 30 years old. So, 5 years ago, Bella would be 6 years old, and then 5 years ago, she would have a newborn kitten, and 5 years ago, Anna would be 5 years younger. And so to the present, we would have to add 5 years to Bella. So 5 years to Bella to know the present age. 5 years to the kitten, newborn kitten, and 5 years to Anna as well. And so 5 plus 5 plus 5 is going to be equal to 5 times 3, which is going to be equal to 15. So we would have to add 15 for the total age of the three children of 5 years ago. So how many years older is Bella than Anna? So now we know that Bella is going to be 6 plus 5 years old, which is going to be 11. So Bella is going to be 11 years old. The newborn kitten is going to be 5 years old since it was just a newborn kitten 5 years ago. And so 11 plus 5 plus A for Anna is going to be equal to 30. So we can do 16 plus A. We got 16 because of 11 plus 5. So 16 plus A is going to be equal to 30. Well, how do we find what A is? A is just going to be simply 30 minus 16. That's going to be A equals 14. And so that's our answer because that's the age of Anna. But we need to find the difference between Anna's age and Bella's age. Remember how Bella is 11 years old and Anna is 14 years old? The age gap will just stay the same. Like randomly, Anna can't be like 1 year old and Bella can't be like 100 years old. The age gap will still be the same. And so we're gonna do 14 minus 11 to find the age gap between them. And 14 minus 11 is gonna be equal to 3. And that means that Anna is 3 years older than Bella. And that's how we got our answer choice C. Problem number 6. 3 positive integers are equally spaced on a number line. The middle number is 15 and the largest number is 4 times the smaller number. What is the smallest of these 3 numbers? So we know that 3 positive integers, meaning that the number cannot be a negative number, they're all spaced equally on a number line. The middle number is 15, and the largest number is 4 times the smallest number. And so if this one is x, if the smallest number is x, then the largest would be 4x. And since we know that these numbers are equally spaced on a number line, that means that the difference between these two numbers or variables is the same between these two. And so 15 minus x to find the difference between them is going to be equal to 4x minus 15. And so we can just solve this. We can add x on both sides, and we're going to be getting 15 is equal to 5x, add 15 on both sides, and we're going to be getting 30 equals 5x. And to find what x is, we can just do divide by 5, and we're going to be getting 6 is going to be equal to x. So we know that 6 is equal to x, and that means that 6 would have to go here. So 6 times 4 is going to be equal to 24. And so 24 would be here. Well, are these numbers even? So 6 to 15 is going to be 9 here. And 15 to 24 is also going to be 9. And so these numbers are equally spaced, and they're just asking what x is. Well, x is going to be equal to 6. And that's how we got an answer choice C. Problem number 7. When the World Wide Web first became popular in the 1990s, download speeds reached a maximum of 56 kilobytes per second. How many minutes would the download of a 42 megabyte song have taken at that speed? Note that there's 8,000 kilobytes in a megabyte. So the maximum is 56 kilobytes per second. And so how much would a download of 42 megabyte song have taken at that speed? So it's going to be 4.2 times 8,000 by 56. And we have to divide by 56 because they said that that is the maximum amount per second. So if we would solve this, and we would be getting or yeah, I'll write this right here. So we would be getting 7 times 6, or sorry, 7 times 0.6. Sorry. Or we can just write 7 times 6 times 8 times 100 instead of 1000 because we would have to multiply the 0.6. So we can just multiply these numbers together by 8 times 7. That's just 100 so. And we can cross out the 8 times 7 here. And we're going to be just left with 6 times 100, which is going to be equal to 600. Well, since they're asking us, what is this? So since they're asking us this divided by seconds, so since there's 60 seconds per minute, we would have to do 600 by 60. Once again, there's 60 seconds per minute. So 600 divided by 60 is going to be equal to 10 over 1, which is just simply 10. And so that's how we got our answer choice B. Problem number 8. What is the value of 1/3 times 2/4 times 3/5 all the way until 1820 to 1921 times 20 over 22? So just like any other AMC-8 problem, such as this one, instead of actually solving this, we can just like cross out the numbers. So since we know that multiplication and division both cancel out with each other, well, we could just like cancel out these numbers. So 3, 3, 4 will be eventually crossed out. 5 will be eventually crossed out. 18 will be crossed out here, and 20 is crossed out. 19 will also be crossed out right there. And so we're going to be left with 1 times 2 by 21 times 22. Well, what's 21 times 22? We can just solve this right here. So 21 times 22. And so, if we solve 21 times 22, we're going to be getting, if we solve 21 times 22, then we'll be getting 21 times 22. We'll be getting 2 here, 6 here, so 6 times 462. And so we're going to be getting 2 over 462. If we would simplify that, then we would be getting 1 by 231. And we just simplify this because we divide by 2 on both the top and the bottom. And then we can be getting 1 over 231. And that's how we got our answer choice B. Problem number 9. A cup of boiling water, 212 degrees Fahrenheit, is placed to cool in a room whose temperature remains constant at 68 degrees Fahrenheit. Suppose the difference between the water temperature and the room temperature is halved every 5 minutes. What is the water temperature in degrees Fahrenheit after 15 minutes? So we know that boiling water is 212 degrees Fahrenheit, and it's placed in a room temperature room. And so it's halved every 5 minutes. So 212 minus 68 is going to be giving us 144. Right? Yeah, 144. And so we need to do after 5 minutes, it's going to be equal to 144 by 2. And we have to divide by 2 because they said that the room temperature gets halved every 5 minutes. So 144 divided by 2 is going to be equal to 72. After 10 minutes, that's 72 divided by 2, which is equal to 36. After 15 minutes, 36 divided by 2 equals 18. And so what is the room temperature in degrees Fahrenheit after every 15 minutes? Sorry, it's gonna be equal to 68 plus 18. Since if we put hot water in a cold room, the room will be heated, not the temperature will not get lower. So we're gonna have to do 68 plus 18, which is gonna be equal to 86. And that's how we got our answer choice B. Does anyone have any questions? Decided to take a hike in the mountains. She left her house at 8 a.m., drove at a constant speed of 45 miles per hour, and arrived at the hiking trail at 10 a.m. After hiking for 3 hours, Ling drove home at a constant speed of 60 miles per hour. Which of the following graphs best illustrates the distance between Ling's car and her house over the course of her trip? So we know that Ling left her house at 8 a.m. So if Ling left her house at 8 a.m., then all of these points over here should be showing 8 a.m. And every answer choice shows that she left her house at 8 a.m. And we know that she drove at a constant speed of 45 miles per hour and then arrived at the hiking trail at 10 a.m., meaning that she drove 45 miles per hour for 2 hours. And so this right here, it's not the speed which she drove, it's actually the distance. So the distance, d, is equal to speed times time. So distance is equal to speed times time, and we know that the speed is 45 miles per hour. So 45 times the time, which is 2 hours. So that means that the total distance she traveled was 90 miles. So all of these should be showing 90. So 90 and they should be showing 10 a.m. So they show 10 a.m., the point right here, and they show 90 miles too. So this one shows 90. This one does not. It actually shows 45. And 45 is just the speed. And we know that it's distance because they say distance right here. So B is not the answer choice. C is not the answer choice either because once again, this shows 45 miles instead of 90 miles because once again, this is the distance, not the speed. This one shows 120, but this one's not 120, it's 90. And so this one's wrong. And this one shows 90, so this one's correct. So it's either A or E. So we also know that after hiking for 3 hours, and 3 hours from 10 a.m. is 1 p.m. So both of these show 1 p.m. And then she drove at a constant speed of 60 miles per hour. So to find a time is equal to distance over speed. This is the formula to find the time. And time is equal to distance which is 90 over the speed which is 60. And once again, they showed us the speed right there, 60 miles per hour when going back. So distance is equal to 90 over 60, and 90 over 60 is equal to 1.5. So 1 and 1 over 2. So that means that she took 1.5 hours to go back home. So 1.5 hours from 1 is going to be 2:30. And so which one of these shows 2:30? This one shows 3, and this one shows 2:30. And so A cannot be the answer, and that's how we got our answer choice E. Problem number 11. Henry the donkey has a very long piece of pasta. He takes a number of bites of pasta, each time eating 3 inches of pasta from the middle of one piece. In the end, he has 10 pieces of pasta whose total length is 17 inches. How long in inches was the piece of pasta he started with? So here, let me draw a rectangle. So this can be a rectangle right here. And so now he has 10 pieces of, or no, he took 10 bites. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means that he has 10 pieces of pasta, meaning that he took 1, 2, 3, 4, 5, 6, 7, 8, 9 bites. So he took 9 bites, resulting in 10 pieces of pasta. And so we know that each bite of pasta is going to be 3 inches. So since we know that each bite will be 3 inches, so we know that 9 times 3. And he took 9 bites of pasta, and each of them is 3 inches. So 9 times 3 is going to be equal to 27. And we also know that the last piece of pasta is going to be 17 inches because they said that the total length is equal to 17 inches. So 27 plus 17, if we add both of them together, we're going to be getting 44. And that's how we got our answer choice D. Problem number 12. The arrows of 2 spinners shown below are spun. Let the number n equal 10 times the number on spinner A, this is spinner A, and add it to the number on spinner B. What is the probability that n is a perfect square number? Well, first of all, perfect square numbers are basically like 1 square, 2 square, 3 square, so it's basically an integer squared. An integer is just like a whole number. So perfect square, in this case, between 50 and 80, since we know that here this is 50, since we know that spinner A is 10 times, so 50 and 80. But they can only be 51, 52, 53, 54, or 81, 82, 83, and 84. Or something like that. And so the only perfect squares that can work are 64, which is 8 squared, and 81, which is 9 squared. So how many possibilities are there? So to find the total number of possibilities, we can just list them out. Or we know that there's a 1/4 chance of getting a 6 here, so 1/4 chance here. And there's also a 1/4 chance of getting a 4 here, so 1/4. And if we multiply both of these together, because we need to know the total possibility of getting 64, then we'll be getting 1/4 times 1/4 times 1/4. And so we can just multiply the top number and the bottom number, which is the numerator times the denominator. And when we multiply that, we're going to be getting 1/16. So that's the possibility for 64. But what is the possibility for 81? Well, it's the same thing. There's a 1/4 chance for 8 and a 1/4 chance for 1. And so we can do 1/16 plus 1/16. And we don't multiply this because we already know that there's a 1/16 chance of getting 81. And we can just add them. So 1/16 plus 1/16 is going to be equal to 2/16, which if we divide by 2, we're going to be getting 1/8. And so the total possibility for n to be a perfect square number is 1/8b. Problem number 13. How many positive integers can fill the blank in the sentence below? One positive integer is blank more than twice another, and the sum of the two numbers is 28. So one positive integer is something more than twice the other. So if we know that one positive integer has to be more than twice another, and suppose that one of the positive integers is x, then if we do x plus 2x, so x plus 2x is going to be equal to 3x. So we know that 28 has to be equal to 3x plus 1. And we just do plus 1 because, or plus anything. So 28 equals 3x plus something. And so that means that x has to be less than 28 divided by 3. And 28 divided by 3 is approximately 9 point something. So about maybe 28 divided by, well, we know that 27 divided by 3 is 9. And so since we know that it cannot be a decimal, it has to be an integer, we can just assume that x has to be less than or equal to 9. So x has to be less than or equal to 9. So in this case, x can be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So once again, this cannot be 0 because it says that it has to be positive integers. And 0 is neither a positive nor a negative number. And so there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers. So that's how we got an answer choice D. Does anyone have any questions on this problem? Okay, problem number 14. In how many ways can the letters in beekeeper be rearranged so that 2 or more E's do not appear together? So first we can list out the possibility where all of the E's cannot be listed together. And there's 5 E's, and there's 4 normal letters like B, K, P, R. So that means that we must start with an E. We can do E, B, E, K, E, P, E, R, E. The 2 or more E's cannot appear together. So that means that each of the E's should be separated with a letter such as B, K, P, R. And so we got this. Then shouldn't that mean that there's only one possibility to arrange these? Well, no, there's not. There's multiple possibilities. Because the B can be arranged anywhere, the K can be arranged here, the P and the R can be switched places with one another. So shouldn't that mean that there's infinite number of possibilities? No, because we cannot just keep rearranging them we cannot just duplicate the answer choices. There can only be one. And so that means that since there's 4 letters here, and we need to arrange them in as many ways as possible, we need to do 4 factorial. Factorial means 4 times 3 times 2 times 1, if it's 4 factorial. If it's 5 factorial, then it's going to be 5 times 4 times 3 times 2 times 1. If it's 10 factorial, it's going to be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So 4 factorial is going to be equal to 4 times 3 times 2 times 1. So if we multiply this all together, then we'll be getting 2, this is going to be 6. Sorry, this is going to be 6. And this is going to be equal to 24. So 4 factorial is going to be equal to 24, and therefore there's 24 different ways to arrange beekeepers so that 2 or more E's do not appear together. Problem number 15. Laszlo went online to shop for black pepper and found 30 different black pepper options varying in weight and price, shown in the scatter plot below. In ounces, what is the weight of the pepper that offers the lowest price per ounce? So here, there's weight in ounces. So this is going to be 1 ounce here. And this is the price. So maybe like 1.1 or maybe 1.15. Okay, so then it's going to be 2 to 2. So since if we divide by, so suppose that this is 1.15. So 1.15 divided by 1 is greater than 1. So 1.15 here is greater than 1. And so this is our closest so far. So this dot right here is closest so far. Well, 2.5 divided by 3 is less than 3 by 3. Since 1 is just equal to 1 over 1, 2 over 2, 3 over 3. So 4 here, it's going to be like maybe 3.9 maybe. So 3.9 is greater than 3.9 over 4 is greater than 2.5 over 3. How about here? This looks to be about 4.5. So here, I'll write this right here. So we can do 2.5 over 3 looks to be lesser than 4.5 by 5. 25 over 30 is less than 45 over 50. And so they're asking, what is the weight of the pepper that offers the lowest price per ounce? And 2.5, so 3 ounces would be costing $2.5. That is the lowest price per ounce. And so that's how we got our answer choice C. Let me highlight the dot that shows that. It's going to be this one right there. That little dot right there. This one. And that's how we got our answer choice C. Problem number 16. 4 numbers are written in a row. The average of the first two is 21, the average of the middle two is 26, and the average of the last two is 30. What is the average of the first and last of the numbers? So, we know that the average of the first two is 21. So the first two can be any number. Suppose that can be maybe like 0 and 42. The average is still going to be equal to 21. But let's think of an easier number, like maybe we can do 20 and 22. So the middle of these both numbers is going to be 21. The average of the middle two is 26. So 22 plus 4 is equal to 26. And so we'll have to do 26 plus 4, which is going to be giving us 30. And so the middle number is going to be 30. And the average of the last two is going to be equal to 30. And there's 4 numbers, so the average of the last two, which is 30, and that number is also going to be equal to 30. What is the average of the first and last of these numbers? So to find the average, we can just add up the numbers. So we can just add up the first and last number, and we can divide it by 2. So 20 plus 30 divided by 2 is going to be giving us 50. Is going to be giving us 50 by 2. And 50 divided by 2 is going to be equal to 25. Or instead of doing this, most of us should know that the number between 20 and 30 is 25. And so that's how we got an answer choice B. It's 25. Problem number 17. If n is an even positive integer, the double factorial n factorial factorial represents the product of all even integers from 2 to n. For example, 8 factorial factorials equal to 2 times 4 times 6 times 8. What is the unit digit of the following sum? So we know that 2 factorial factorial plus 4 factorial factorial plus 6 factorial factorial plus 8 factorial factorial plus 10 factorial factorial. 10 factorial factorial, well, 10 times any number will be ending in a 0. And so the cycle repeat again. So 2 factorial factorial, 4 factorial factorial, all the way until 10 factorial factorial, which will be ending in a 0, which will be the unit digit. And then shouldn't the answer be 0? Well, no, it shouldn't be 0 because we don't know that, because this number ends with a 2022. If it would end in here, then it would most likely end with a 0. So we cannot guarantee that. And so we can just do 2 factorial factorial plus 4 factorial factorial plus 6 factorial factorial plus 8 factorial factorial. And we can just add up the unit digit up. And so, once again, this is just the even number, so it won't be that hard to multiply them. And we will not have to do 10 factorial factorial because we will know that it will always end with a 0. So we can start by doing this and multiplying this. So 2 factorial factorial is going to be simply 2 times 2, it's just 2, plus 4 times 2, which is going to be equal to 8, plus 6 times 4 times 2, which is going to be 6 times 8, which is 48. And this, an 8 factorial is going to be 8 times 6 times 4 times 2. And 6 times 4 times 2 is 48. So 48 times 8 is going to be equal to 384. And we can just add up the unit digits. So 2 plus 8 is going to be giving us 10. Plus 8 will be giving us 18. Or, yeah, I'll just write this right here. So 18 plus 4 here is going to be giving us 22. And so a unit digit is going to be ending with a 2. And once again, I just added up the unit digit here. So 2884. And that's how we got to answer choice B. Also, if you want, you could just like multiply all of these numbers or just the even numbers for in this case, and you'll still be ending with a 2. Problem number 18. The midpoints of 4 sides of a rectangle are -3, 0, 2, 0, 5, 4, and 0, 4. These are all the coordinate points of the rectangle. And what is the area of this rectangle? So let me try to draw a graph here. And okay. So now we can try to graph these points on this graph right here. So -3, 0 should be somewhere around here. So -3, 0, -3, 0. And the next point should be 2, 0, which is about here maybe. This is not a perfect graph, but it's an estimate, so it's pretty close. And then this will be 5, 4, which will be somewhere here. Or no, that's not 5, 4. This is 5, 4. So 5, 4 will be somewhere here. 5, 4. And this can be 0, 4, somewhere here. 0, 4. And this should be looking something, or yeah, this should be looking something like that. So it looks like a parallelogram. So what is the area of this? Well, since we know that this is the midpoint, these points are all of the midpoints, then we know that from here to here, it should be 5 units, so 5 here. Then if this is the midpoint, then it should be 5 up there too. So it should be looking, or it can be 5 down here too. Since if it's here to here, then it should be here to here as well. So this should be 5 units as well. In total, it's going to be 10 units. And so the length of this rectangle, it should be 10. And from here to here should be 8 because we know that this is 0, 4, which means that it should be 0, 4 right here as well. So 4 units, and so it should be 8. So this is 8 by 10. That's 8 by 10. So we can do 8 times 10. But since this is a parallelogram, this is 8 by 10. Since this is a parallelogram, and we're just measuring from this whole entire rectangle over here, and we know about this whole entire rectangle here, we would have to divide by 2 because the whole parallelogram is not taking all of that space. It's just taking half of that space. And this would make sense because of this part. We would move this part, then this whole part would be empty. So then we would have to do 8 times 10 by 2, which will be giving us 80 divided by 2, which should be giving us 40. And that's how we got to answer choice C. Problem number 19. Mr. Ramos gave a test to his class of 20 students. The dot plot below shows the distribution of test scores. Later, Mr. Ramos discovered that there was a scoring error in one of the questions, and he regraded the test, awarding some of the students 5 extra points, which increased the median score to 85. What is the minimum number of students who receive extra points? Note that the median test scores equals the average of 2 scores in the middle if the 20 test scores are arranged in increasing order. So in this note right here, they're just telling us if suppose that the dot plot should be looking something like this. This is just an example. It should be looking something like this here, 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 or we can do that. Or yeah, here. This is just an example right here, and it could be something like this. So if we want to find the median, then we would just start crossing out this from left to right. So if we cross this out, and cross this out, then we'll be left with nothing. And so that means that the median score must be between these two. And this can be 1, 2, 3, 4. And so to find the median of these two, so to find the median of this whole entire dot plot, then we would have to do all of this, so 2 plus 3 divided by 2. And so the median score would be 2.5. This is just an example, so instead of all of this, then we would have to go to this dot plot here. So we can start by crossing off from left to right here. And when we do this, and here, when we do this, or wait, here, I'll make it a bigger image. Okay, so here we can cross out 1 from the left, 1 from the right, 1 from the left, 1 from the right, 1 from the left, 1 from the right, and keep going. Okay, and then we have 4 dots here. And so the actual median when Mr. Ramos made a mistake was that it should be 80. But then he told us that he regraded them, awarding some students 5 extra points, which increased the score to 85. So if it increases to 85, and there's 4 students who have 80 so far, then if we move 2 of them, suppose that we move 2 students here, then we would have to find the median between 80 and 85, which will be 2.5, or approximately that. And so if we do 3 students here and 1 student here, then it'll be like 81.5 or somewhere around that range. But we know that's just 85. There's no like in between, so it's just 85. And so in this case, you have to move all 4 students to 85, meaning that that is the least number of students who he can give extra points to. And that's how we got an answer choice C, 4. Problem number 20. The grid below is to be filled with integers in such a way that the sum of the numbers in each row and the sum of the numbers in each column are the same. 4 numbers are missing. The number x in the lower left corner is larger than the other 3 missing numbers. What is the smallest possible value of x? So they're asking for the smallest possible value of x. So the sum of these 3 numbers can be anywhere. It can be like 100. But the only condition is that they have to fill the magic square. And also, this is called a magic square, since we know that the sum of each row, each column, and each diagonal or should be like the same. Or I don't know if it has to be the same in this diagonal in this case, but it said that the rows and the columns in each row and each column are the same. And so, since we know that each row and each column are the same, then we can find the magic square, the number. So the total would be -2 plus 9 plus 5. So that should be 7 plus 5, which is 12. And so the sum of the magic square is going to be 12. So whether you take any row or whether you take any column, the sum should always be equal to 12. So in this case, so we can take the second row. So if we take the second row, then these two should be equal to 13. Since there's a -1 here, so if we do 13 minus 1, it should be giving us 12. And so so the sum of these two should be equal to 12. I'm sorry, 13. So if one of these, or if both of these are equal to 6 and 6, then 6 plus 6 will be giving us 12, and that is the highest number possible. So if that's not possible, then we need, suppose we need 7 and 6. 7 plus 6. And when we add both of these together, we should be getting 13. So we could try this out right here. I'll be changing the color to pink. So this can be 7 and this can be 6. This can work because it's going to be 7 plus 6, which is 13 minus 1, which is going to be equal to 12. But in this case, will this work? So negative 2 plus 7 will be giving us 5. 5 plus 7 is going to be equal to, 5 plus 7 is going to be giving us 12. So here we have 8 plus 7, which is going to be giving us 15. And 15 minus 3 will be giving us 12. And here we have 9 plus 6, which will be giving us 15. 15 minus 3, which will be giving us 12. So in this case, we have this so far. And all of these can work right now. So once again, this is negative 2 plus 7, which is going to be giving us 5. 5 plus 7 is going to be giving us 12. So 12, so this is going to be giving us 12 as well. This will be giving us 12 as well. But then let's see that but there's no 7 in this answer choice. And so even though 7 can work, well, we have to think of any other option. So suppose that we can do 6 here and 7 here. So we want the smallest number. So negative 2 plus 6 is going to be giving us 4. And so 4 plus 8 will be giving us 12. And then 12 plus, or sorry, not 12, 8 plus 8 will be giving us 16. And so this will be negative 4. And 9 plus 7 will be giving us 16. And 16 minus 4 will be giving us 12. And so it can be either 7 or 8. And these are the only two options possible. But there's no 7 in this answer choice. And so that's how we got an answer choice D. Problem number 21. Steph scored 15 baskets out of 20 attempts in the first half of the game and 10 baskets out of 10 attempts in the second half. Candace scored 12 attempts in the first half and 18 attempts in the second. In each half, Steph scored a higher percentage of baskets than Candace, but surprisingly, they ended with the same overall percentage of baskets scored. How many more baskets did Candace score in the second half than the first? So this is about, and this 15 over 20 is about 75%, because it's 3 over 4, which is about 75%. And 10 over 10 is 100%. And so for 12, well, 75% of 12 is going to be 9. And so maybe we can do 8 over 12, which is going to be 66%. About 66%. And so instead of 9 over 12, since it has to be an integer, since we can't get like a 0.5 of a basket, we can do 8 over 12. And instead of 18 over 18, we can do 17 over 18. And if we calculate the average and everything, we should be ending with the same average in the total percent. And so when we do this, we should be getting 17 minus 8, which is going to be giving us that. And we have to subtract because we know that how many more baskets did Candace score in the second half than the first? So that's going to be giving us 17 minus 8, which is going to be equal to 9. And that's how we got our answer choice C. Problem number 22. A bus takes 2 minutes to drive from one stop to the next and waits 1 minute at each stop to let passengers board. Zia takes 5 minutes to walk from one bus stop to another. As Zia reaches the bus stop, if the bus is at a previous stop or has already left the previous stop, then she will wait for the bus. Otherwise, she will start walking towards the next stop. Suppose that the bus and Zia start at the same time towards the library with the bus 3 stops behind. After how many minutes will Zia board the bus? So here, the bus takes, suppose in 5 minutes, Zia will be in at this stop. While the bus, on the other hand, will be one here, and it'll be waiting at this stop. So I'm gonna draw an open circle for the bus waiting. After another 5 minutes, Zia will be over here. And for the bus, after another 5 minutes, it'll be 6 minutes here, 7, 8, 9, 10. So it'll be in the middle of stop 3 and 4. After 10 minutes, and after another 5 minutes, so 15 minutes, Zia will be over here. And the bus, on the other hand, after 5 more minutes, it'll be 12, 13, 14, 15. The bus will be over here. And since the bus is on the previous stop before Zia, Zia will just wait. And the bus will be coming in 2 minutes and the bus will have to wait for her, right? And while the bus is waiting, Zia will board the bus. And so the bus will take 2 extra minutes. So when Zia reaches the stop, the bus will be 2 minutes behind. So that will be giving us 15 plus 2, which will be giving us 17. And that's how we got our answer choice A. Does anyone have any questions on this problem? Okay, if no one has any questions, I'm going to continue on to question number 23. So, question number 23. A triangle or a circle is placed in each of these 9 squares by 3 by 3 grid. Shown below is a sample configuration with 3 triangles in a line. How many configurations will have 3 triangles in a line and 3 circles in a line? So this one's kind of a hard problem, so please let me know if you have any questions. So in this grid right here, there's going to be triangles and circles. So only 2 shapes here. So there's only 2 shapes here. And so what is the possibility that we'll have 3, or how many ways can there be 3 triangles in a line? So there's one line here, one line here, and one line here. So that means that there's 3 ways for the triangles, or for the 3 ways to be in vertical. So vertical meaning this way. And there's 3 ways for the triangles for 3 rows. 3 columns. For the circles, on the other hand, so if one of these, suppose that this one is already taken, then the circles will have 2 more. So 2 more ways to be possible. And suppose that this one is taken by the circles, meaning that there will be 1 more way for the triangle or circles to be arranged. But this one can be a triangle or a circle. This one can be a triangle or a circle, and this one can also be a triangle and circle. But this will not be times 6. We'll have to multiply by times 8 because we'll have to multiply all the possibilities. So 3 times 2 times 8 will be giving us 6 times 8, which will be giving us 48. But then we'll have to do 48 times 2. Since this is only vertical, we'll have to do horizontal as well. This is columns. This is rows. This is vertical. This is horizontal. So the difference, or how I like to know the difference between vertical and horizontal, is that in V stands for vertical. Meaning that in vertical, the lines go up and down here. And so I like to think of vertical going up and down, and horizontal, on the other hand, horizontal, the line goes like this, just like a number line, where you can think of where you can think of this one and this one. In H, it's just like the 2 points on a line. Once again, in H, you can think of it like this, and you can just keep extending the line or something like that. And horizontal is this way, and vertical is this way. So since we know the possibilities for vertical, we'll have to do the same one for horizontal. And if we do the same thing, then we'll be getting 48 times 2. And that will be giving us 96. Then shouldn't the answer just be 96? No, because we're overcounting. And let me explain you why. So what I mean by overcounting is here. What I mean by overcounting is this. So we have a square right here, or something similar to a square. And we have something else, we have another square over here. Or, yeah, here. We have another square over here. Okay, so now let me draw the grid right here. So something like this. Here. Okay, so we have something like this. And now we just need the triangles and the circles. So here, suppose that we have a triangle, 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 triangle. And then we also have circle, 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 but instead of placing the circle there, or sorry, instead of placing the circle there in this grid, we're going to place it in the middle. We have circle, circle, circle. Now, how many possibilities are there to arrange these two? So in this one, we know that there's 8 different possibilities. And so suppose that this can be maybe, which is a different color, maybe this can be triangle, circle, triangle. And this can also be triangle, circle, triangle. Are these two squares the same configuration or different configurations? Well, these two are different. Okay, that's right. But then, now, suppose that this can be circle, 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 and this can be circle, circle, circle as well. Well, the colors don't really matter for now. Or here, if you want, I can change this to red. But then would they be the same configuration or different configuration here? These are the same colors. So would these be the same configuration, different configurations? Well, I thought these were different, but why are they the same now? So these are the same. That means that we're just over counting. So that means that we're just like, we're counting these twice. And this can apply the same thing to triangle being in the middle or the circle being in the middle. Means that we're over counting. And so instead of 8 over there, it should actually be 3 times 2 times 6. Since we're over counting twice. So plus 3 times 2 times 2. And we don't know twice times 2 again, once again, because we're over counting. And we got 6 because here on this page, here, let me zoom out here. On this page, these are all of the different configurations which we will not be counting twice. Where there can either be 2 triangles in a line or 1 triangle in a line. And 2 circles in a line or 1 circle in a line. So these are all of the 6 ways which are possible, which we are not over counting. I mean, there's like multiple different ways in the top one, but these are like one of the 6 ways. And last time we found 8 ways, and if we do 96 as our answer choice, then we will get that question wrong. And so we can't do that. And so there will be 3 times 2 times 6. So here, we'll have to do 3 times 2 times 6 and 3 times 2. We'll have to add both of them together. So 3 times 2 will be giving us 6, and 6 times 6, which will be giving us 36. So 36 plus 3 times 2, which will be 6. So 36 plus 6, which will be giving us 42. And once again, don't forget that this is just the vertical ways, and there's also the horizontal ways as well. Once again, vertical and horizontal. So vertical going up and horizontal going like in a line. So we'll have to do 42 times 2. And if we multiply 42 times 2, then we'll be getting 84. And so 84 will be our final answer, not 96, not 42. And that's how we got our answer choice D. Does anyone have any questions on this problem? Please unmute if you have any questions, or you can raise your hand. Okay, so if no one has any questions, then we'll go on to problem number 24. The figure below shows polygon A, B, C, D, E, F, G, H, consisting of rectangles and right triangles. When cut out and folded along the dotted lines, the polygon forms a triangular prism. Suppose that AH is equal to EF is equal to 8 and GH is equal to 14. What is the volume of the prism? So let me just label the side lengths. So we have AH is equal to 8 and EF, where's EF? EF, which is also equal to 8. And GH, which is going to be equal to 14. But since we know that this is a square right here, we know that this side is also going to be equal to 8. And 14 minus 8, which will be giving us 6. So JG will be equal to 6. And now we have this side length and all of these side lengths. And so, on the actual AMC-8, you will be having paper, but you won't be having scissors. So you're just gonna try to visualize it. Just do your best on visualizing. But right now I do have a paper. I'm not sure if you can see it. I do have a paper right here. Yeah, I have a paper right here, which I did draw this, and I'm gonna cut it. And all the side lines or some of the side lines are labeled right here. And so you're gonna try your best to visualize this on the actual AMC-8. You'll be having paper, but not a scissor, and you'll be having a pencil as well. And so they'll be providing all the paper and the pencil, so just try your best to visualize. But for right now, I'll be showing you a model here. So here I have this right here. So here I'm gonna be folding it. And so I also have tape here and on the AMC you will not be having tape, and they won't allow you to get your own tape either. So don't get tape there wherever you're taking the AMC. And here I'm just gonna stick these together. And I'm almost done. So try to visualize this here, and I'll be showing you the model in a few seconds. Okay, so I have a model. It's not perfect, but yeah, here. It's not a perfect model, but I did label all of the side lines. And so here, we need to find the total area. And we know that the area will be equal to, area is equal to base times height. And the base will be equal to length times width times height too. Here, times height. And so in this model, which I labeled, it'll be here. This is the base here, and it's gonna be equal to 6 and 8. So 6 times 8, and 6 times 8 will be giving us 48. And 48 times 8. Well, if I do 40, and this is also the other, this is like the one of the triangle here. So 48 times 8 divided by 2. We have to divide by 2 since it's a triangular prism. We'll have to do 24 times 8, which will be giving us 192. Forgot to explain. This is how I simplify this. I just divided it by 2 so that the denominator can be equal to 1, and I just divided the numerator by 2 so it can be easier to calculate this. And so we got 192. And that's how we got our answer choice C. Once again, here's my model. So does anyone have any questions on this problem? Okay, if no one has any questions, then we'll go on to question number 25. So this question is also kind of hard, but it's easier than 23, but it's also kind of hard too. So a cricket randomly hops between 4 leaves, on each turn hopping to one of the other 3 leaves with equal probability. After 4 hops, what is the probability that the cricket has returned to the leaf where it started? So this is a special kind of leaf because it is a leaf where the cricket started. And this can be A, B, B, B. And these 3 are B because these are not the leaf where the cricket started. And the cricket has equal probability, but then the cricket, we want to find the probability of going back to the leaf where it started from. And so this is the cricket. This is the location the cricket started from. So we want it to go back to the original place. And so we're going to be doing A to B. So what is the probability that we'll be going A to B? Well, that is the only place it can go. A to B is the only place it can go. From A, it can only go to B. Because it can't just hop in their own leaf and just land in the same place. It has to keep moving. So A to B is one probability, so it has to go. So it's a 1/1 probability. Well, what is the probability it will be going from B to B? So from B to B, it's actually going to be 2 over 3. Suppose that the cricket is here, can go 1 over 3, 1 over 3, and 1 over 3. But then we want B to B because we want it to go here. So it's going to be 1/3 plus 1/3, which is 2/3. So B to B is 2/3. And then from B to A, it's going to be, so I'll write this right here. So from B to A, it's going to be equal to, from B to A, it's going to be, so suppose that B to A is going to be 1/3, right? Because there's a 1/3 chance from it going from B to A. So these are the 3 possibilities here. So what is a cycle that can go from 4 hops from it returning back to A? So there's, here, suppose it takes a whole entire loop. So A to B to B to B to A. Here, let me show you the cycle here. So A to B here, that's A to B, and then from B to B, and then from B to B here again, and from B to A. So that's 4 hops here. 1, 2, 3, 4. A to B is 1, and we can 1, and B to B is 2/3, and B to B once again is 2/3, and B to A is 1/3. And we will have to multiply this since we're finding the probability. We have to multiply this. And when we do this, we'll be getting, just multiply the numerator and the denominator by themselves. And we'll be getting 2 squared over 3 cubed, which is 4 over 27. And now we'll have to think of another possibility. So we can just try to visualize all of the possibilities, and there's only 2 possibilities that we can actually do. So A to B to B to B to A, or we can go to A to B to A to B to A, right? No, A to B, 2, 3, 4 here. Let me explain this. I'll be using a different color here. A to B, that's one possibility, and then B to A is another possibility, and then A to B is another, and B to A. And these are, and once again, all of the B's are the same, and all of the A's are also the same. So they can only be one starting leaf, and yeah, so A to B, and A to B, I mean B to A, and then A to B, and then B to A again. Well, we can start here. So all of the B's are the same, and all of the A's are the same as well. And now we could just, once again, we found out all of the probability here. We could just substitute all of this in here. This is basically like a formula or like their starting point here. So A to B is going to be 1. And B to A is going to be 1/3. A to B, once again, is going to be 1, since there's only one chance. And B to A is going to be 1/3 again. And now we can just multiply the numerator and the denominator, and we'll be getting 1 over 9. And 1 over 9 is going to be equal to blank over 27. And when we multiply the bottom, so 9 times 3 is going to be equal to 27. That means that 1 times 3 should be equal to 3. So 1 over 9 is equal to 3 over 27. And now we can just add all of these up. So 4 over 27 is our first possibility here, plus 3 over 27 is going to be equal to 7 over 27. And that's just our final answer. Answer choice E. This, once again, this is our first possibility, and this is our second possibility. And that's how we got our answer choice E, 7 over 27. Does anyone have any questions on whatever we talked about so far or about any problems?